So in this video, we want to talk about finding the missing angles using something called inverse trig functions. And it's a pretty fancy name for a pretty straightforward concept. So let's get started. Let's take a look at this right triangle right here. I've given you the three sides, right? So we've got a 5, we've got a 7 centimeter, and then this one over here is the square root of 74 centimeters long. And so that's going to be, over 8. Because 8 times 8 is 64, but 9 times 9 is 81. So it's somewhere between 8 and 9. So if you think about this, we know all the sides of this triangle. We should be able to then figure out the missing angles. So let's call this angle X. Let's call this angle Y. But first we need to recall that, and let's just look at let's just consider angle X for a moment. So let's recall and remember that the sine of X is equal to the opposite over the hypotenuse. So in this case, without simplifying or rationalizing the denominator, we would say 7 over the square root of 74. We would say that the cosine of X is equal to the adjacent side over the hypotenuse, or 5 over the square root of 74. And then the tangent of X, of course, is opposite over adjacent, or 7 over 5. And so we know all these relationships. So the question would become, if you know that the sine of X is 7 over the square root of 74, and you know all this stuff that we just wrote out, how can we figure out what angle X should be? And that's what we're going to look at in this video. We're going to come back to this problem after we look at a special triangle. Then we'll apply kind of what we learned from the special triangle to solve this problem. Okay, let's get started. All right, so let's get started. I'm actually going to get rid of that triangle that I drew and do a new one because I think this will be a better example. Let's go back to our 1, 1, square root of 2. And so right off the bat, you should recognize this as a 45, 45, 90. And so we know that the angles are 45, and that's why I want to use it to explain the inverse functions or inverse trig functions. So let's call this one X, and we're trying to figure out what angle X is. Again, we know it's 45 because we know that this whole right triangle is just half of the square. And when you do a diagonal in a square, so I can draw this out for you, if we replicate this triangle and flip it over, it's a one square, and the diagonal of a square bisects this angle. So I know that this angle here is 45 and this angle is 45, so this must be 45. But let's look at figuring out why it's 45 a different way. And one way to look at it is we already know that the sine of X is equal to 1 over the square root of 2 in this case. And so there's got to be some sort of function out there that can tell us, if we already have the ratio, if we already know the opposite side length, the 1, and we already know the length of the hypotenuse, what angle is that? And there is actually. It's called the inverse function of the inverse sine function. Sometimes we'll call it arc sine, sorry. Sometimes it'll be sine with a little -1 kind of as an exponent, and they all mean the same thing. And what they mean to ask is, if this is the sine of X, then what is the angle X? So if I was to take the inverse sine of 1 over the square root of 2, it's going to say 45. So like if I go to my calculator, for example, and all of the calculators we're going to be using in class have these inverse sine functions, and you can find these on, you can Google a calculator and find one online that has this, or even your phone, I think, has these. So I'll type in the inverse sine of 1 divided by the square root of 2, and it pumps out the angle 45. The computer tells me right away that the angle must be 45. And that's not rocket science, right? We already knew that that was 45 degrees. But that's what the inverse function tells us. So we could say, okay, I know that the cosine of X in this case is the same thing. It's 1 over the square root of 2. I know that the tangent of X in this case is 1 over 1 because it's opposite over adjacent, 1 over 1. And so what must x be? What must the angle be for these ratios to hold true? And again, I could say, okay, well, what is the inverse cosine of 1 over the square root of 2? What is the inverse tangent of 1 over 1? And it's going to pop out the angle. The calculator's automatically going to tell me 45 degrees. We're going to look at this more in class, but let's apply this knowledge now to solve for the missing angle in that first problem we saw. So here we are. We have a right triangle. We know one side 7 centimeters. We know the one leg is 5 centimeters, and the hypotenuse is a square root of 74. So we want to know what x and y are. What is angle x? What is angle y? And we would use our calculators to help us with this. And so we could really use a variety. I mean, we could use the inverse sine, we could use the inverse cosine, and the inverse tangent. And by the way, if something's prefaced with this like arc, so like arc cosine, it's the same thing. That means the exact same thing as the inverse cosine. The arc tan is the same thing as the inverse tangent. So arc and then the little -1, those are synonymous, mean the same thing. We call these inverse functions. And we'll talk more about why we say that and how these work in class. But for right now, let's kind of get this skill down. So something you might do is, one thing you might do is think, okay, let's find the sine of x. So the sine of x, again, should be 7 over the square root of 74. So this means then if I take the inverse sine of 7 over square root of 74, it should tell me whatever number I get, I'm going to get a number here, that should be angle x, okay? So we've solved for x, but we haven't solved for y yet. And I'm going to leave you here, okay? And I know some of you might be thinking, I kind of understand what's going on, but I'm not exactly sure how to do this yet. So what I'm going to ask you to do is get a calculator out and actually plug this in. Find your inverse sine function, put in 7 over the square root of 74, and see what angle you get. And do the same for y, but in the case of y, you have to use an inverse function for specific to y. So for example, we could use something different than sine, like let's find the cosine of y, just for sake of variety. So the cosine of angle y is the side adjacent over the hypotenuse. So in this case, the cosine of y is 7 over the square root of 74, or the same thing as the sine of x was. And so then we could say, okay, so what's the inverse cosine of 7 over the square root of 74? And that should tell me angle y. So what I'm going to ask you guys to do is to figure out what angle x is, what angle y is, two different ways. Two different ways each. So I've done the inverse sine to find x, but I bet I could do an inverse tangent to find x. I could do an inverse cosine to find x. So you could use all the inverse functions to figure out the missing angles if you know the sides of the triangle. All right, good luck, guys.